Okay, in this video, we're going to be solving what's called literal equations. A literal equation is basically a formula, and to where you might have all variables with very few numbers. So what we're doing with literal equations is we're trying to get variables by themselves. Okay, they're going to tell you a certain variable. We're going to solve this formula, and we'll talk about later on the reasons why we would want to solve a formula. But the biggest thing to know again is identify all your terms. And in this a squared plus b squared, this equals c squared, this is very recognizable. This is Pythagoras' theorem. And the biggest thing I want you to remember is make sure that you know whether each term is positive or negative. Like we could put a plus sign in front of that a squared and in front of the c squared both because they're both positive. The reason that's important is because now in order to move any term, any of those three terms from one side of the equal sign to the other, all you got to do is simply, if it's plus, make it a minus. If it's minus, make it a plus to move it. Now, what I like about literal equations is most of the time you don't have to combine any like terms. So they're actually easier than actual regular equations. So first step, always move any terms that you can move. A plus to a minus or a minus to a plus makes it easier. The next case is, in this one, I've underlined b because that's the variable I wanted to get by itself. So since b is being squared, always remember to move anything, you're going to do its opposite. So in order to move a square to the other side, we're going to do a square root. And technically, later on when you get into Algebra 2, you know that you would actually have to do plus and minus. But since this is geometry and we're talking about side lengths, we don't have to worry about the negatives. So your value of b is now by itself, and it will equal the square root of c squared minus a squared, and you're done. Next problem, let's try to get the b by itself in this. Now, fractions are, once you get used to them, a little bit trickier at first, but they're easy to work with. Because if you think about the way we're going to move this, now notice there's no pluses or minuses that we could get rid of here. Everything's being multiplied on that right side. So in order to get rid of that 1/2 and that h, which is what we're going to have to do to solve for b, since they're all three being multiplied, in order to move those things to the other side, we're going to have to divide. Now, division by fractions, you learned back in elementary school to actually divide two fractions. You have to take that second fraction, you have to flip it upside down, and you have to multiply instead. So the first thing I'm going to do, and you can do one at a time, you can do two at a time, the better you get at it, the more you can move things to the other side in bulk. So since 1/2 is being multiplied by this, we're going to have to move it over, and we're going to have to divide by 1/2. Which, from what I just told you, division by 1/2 is the exact same thing as multiplying by 2/1, or 2. So to mark out the 1/2, to move it to the other side, we simply have to multiply the other side by 2. Flip and multiply. b is nearly by itself. Now all that's left is the h. Since b is being multiplied by h, we're going to divide by h, and you're finished. b is actually equal to 2 times the area divided by the h. And we know that's the formula for the area of a triangle. A few more. Next one. So we're wanting to get this a by itself. Now, we can't move the a. It's in parentheses. It's in what I like to call, it's in a house. And you can't move the house until you move everything outside of the house. So what we're going to do first is we're going to do the exact same thing we did on the last one. Since 1/2 is being multiplied by these things, we're going to move it over by, we're going to move it over to by dividing. Dividing by 1/2 is the same thing as from the previous example, multiplying by 2. The next thing, h is also being multiplied by the house. So we're going to move it over by dividing. That looked a lot like last problem. So now you have 2 times the area divided by the height. This is the area of a trapezoid problem. Equals a plus b, and we're wanting to get the a by itself. So now it's pretty simple. You take the 2a over h, and to get a by itself, we're simply going to minus b. A plus b, when moved over, becomes minus b, and you're finished. Next one, now we're getting a little trickier on this one. This is called Heron's formula. It's another way of finding the area of a triangle. Now, remember what I just told you. You can't move the things inside of a house until you move the house itself. So this big square root, we're going to mark out, come to the other side and do its opposite, which is squaring. So we now have a squared equals s times s minus a times s minus b times s minus c. And we're wanting to get this c by itself. Now, this is what's nice. Notice that all three of these things are actually being multiplied by that last set of parentheses. And we can move it in bulk. Since they're all being multiplied, we can divide by all three. So a squared divided by s times s minus a times s minus b is equal to s minus c. And notice that since everything outside the house is gone, we no longer need those parentheses. Now, the next step, later on, I'll talk a little bit more about, I'm kind of weird about this, but anytime I see a minus that I'm trying to get by itself, most of the time I would actually move that over and move this back over in its place to save me a step, and it makes it a whole lot faster. But I will go ahead and show you the whole steps for the sake of the video. So next step, I'm going to come over here to the side. I'm going to move this s. Since it's a term, it's a plus s. When you move it to the other side, you're going to now have a squared over the stuff we just wrote minus that s, and that's equal to a negative c. And we still have to get rid of that negative. Since it's like a negative 1, we're dividing by negative 1. Make sure you move both things or divide both things on that other side by that negative 1. And all that happens is the first thing becomes a negative, the second thing becomes a positive, and now c is by itself. So there's the solution for Heron's formula and one of the three side lengths. We're going to do one more, and this is recognizable as the law of cosines. So remember what I told you, if at all possible, we're going to move any term. There's a plus b squared and a plus c squared. We're going to move any term across the equal sign first, if at all possible. So plus b squared becomes minus b squared, plus c squared becomes minus c squared. And then we have the rest of our formula. Now, in order to get a by itself, we now have a couple other things to get rid of. Notice that this negative 2 and b and c, since they're being multiplied by the cosine of a, we're going to move them over by simply doing divided by on the other side. The whole side divided by negative 2bc. And now we've nearly got that a by itself. All we have left is the cosine. In order to move a cosine, the opposite of cosine is inverse cosine. So we're going to come to the other side, and to move it, we're simply going to do the inverse cosine of everything. And you've got a by itself. So a is equal to that formula. And that's going to be very helpful later on if we're looking for angles and we're given three side lengths and we really don't want to solve an equation every time. And that's the whole purpose of doing these is, what if I give you three side lengths? And do you really want to plug in those three side lengths every time and solve this formula over and over and over? No, it'd be really nice if we had a different formula to where we could just plug in those three side lengths and it automatically, without solving an equation, it automatically tells you an answer. And that's the purpose of solving literal equations.